Hello everyone, I'm Lars Reger, I'm the CTO of NXP Semiconductors, and I'm at our booth here in Las Vegas at the Consumer Electronics Show 2020. And what I would like to do today is to show you what we have lined up here for our guests with the theme, a world that anticipates and automates. We are the company that can enable most of the smart connected devices that you will see in the next 5 to 10 years out there in the market. And how we're going to do this is what I'm going to show you briefly here in a walkthrough over the booth. So if you look into my jacket, here what I'm wearing in my jacket pocket is an ultra-wideband tracker. And ultra-wideband is one of our newest, hottest technologies for very smart and accurate positioning. So you can do asset tracking, my jacket can be tracked, and a lot of our demos are reacting to this beacon in my jacket. For example, this globe here behind me that is showing what NXP can do to the smarter world. It will be a globe that is traveling also our sites throughout the year. And if I move closer to this globe, you will see these bluish cubes changing color. Just as I'm walking over here, you will see suddenly the cubes are lighting up in a red way. This is of course what you can also see in your house, with your infrastructure, with your car reacting to you approaching, opening up the doors, switching on the light, and so on. We have our booth, if you're looking this way, lined up in a way. We have 3 iconic demos over here covering our main verticals. So automotive in the middle, industrial, and smart home, mobile, and IoT to my right side. So follow me quickly on, and then after this discussion of the eye-catcher demos, I will show you all the technical detailed demos in the second section of this area here. So we have here a transparent car where you can see basically all leading-edge automotive technology that we have lined up. So to the front here, if you look with me to the front of the car, what you can see is our leading radar solutions, front radar, antenna in package, very tiny radar. And what you see here on the screen is the active radar sensing signals that you can see when I start moving here. So you see the Doppler signals of the radar. Then if you follow me further on, what you can see here is the application processing that we use in a lot of car activities. So the electronic instrument cluster, for example, you will see a blue box for autonomous driving and ADAS. You will see the data pumping and data switching devices here, our Ethernet switches, for example. You will see secure elements in the vehicle. Here, center stage, you will see our battery management systems. Really, really hot, highly precise, highly accurate, and highly functional, safe electronics that is making sure that your batteries are never overcharged and optimally managed. We have the general purpose controllers, of course, for all body electronics and autonomy functions. And to the rear side of the car here, you see V2X electronics, where we are very successful with Volkswagen and GM in the market already since a couple of years. You have the green box for powertrain management, and of course the surround view and surround detection capabilities with radar and vision. Plus what you see here, this big PCB down here in the car is our most advanced, most intelligent amplifier system for infotainment. So this big unit here is driving premium sound. For example, you can see it here in a demo with our partner Harman. Harman is using for the top-notch audio systems, our amplifiers in the best surround sound systems in vehicles worldwide. So looking with me over there to the industrial segment, what you can see here now is you'll see basically all the product portfolio that we have as NXP to build these type of industrial robots. Everything that you need in precision analog electronics, everything that you need in powertrain, so motion parts for the power electronics, everything that you need in sensor electronics, and last but not least, but very, very important, the secure connections to the cloud as well. So in other words, what we are using is we are using the chips of the German passport, give them an I2C interface so that robots can connect to these chips and let these robots run around with their own little passport. So this robot is connecting to the cloud in the same way like Lars is at the United Airlines gate connecting to the gate with my passport. This robot is talking to the cloud in this safe and secure way as well. So having this, of course, similar electronics are needed for the smart home as well. And if you just follow me over there to the smart home demonstrator. Excuse me for a second. So what you can see here also on the smart home demonstrator basically is all the ingredients that you need to manage the home of the future. So it is reliable and secure privacy in your house. It is personalized, seamless experience. You don't want to have barriers in your house. You want to have your doors opening up like Sesame open up, of course via the ultra-wideband beacons that I have in my pocket. And of course, what you want to have in your house is you want to have your house as environmental friendly as possible. So you want to have as green, carbon neutral electronics as possible. So energy saving is of course of the essence. So all of these three iconic demos, I'm going to show you now the ingredients that we have in more than 50 separate demos and use cases that we have here in the booth. So if you follow me to the automotive section and I walk you through to the AI section on the IoT. A short stop here. This is one of my favorite demos here at the booth. It is the so-called executive tracker. So all us executives, we are wearing these beacons in our jackets. And what you can see here on this turning element here, you can see, for example, my name in front of this TV screen here. And Steffi and Lars are close to each other here at the moment, trackable. You can see all the others that are wearing these beacons. Steve is, for example, walking in the back of the booth. So you can see where we all are, just to show how accurate by the centimeter, by the millisecond these solutions are, and they can exactly position you where you are. Very important for the car keys, very important to steer all the assets in your house. So basically to seamlessly open up your front door, to let your music in your house follow you, to switch on your walkway light while you're walking from the car to the house, all of these things seamlessly. If you follow me. So now what you're going to see here is basically the infotainment section of the vehicle. Come on closer.
Big messages, stretch screens.
Here you have an F150 windscreen of a real Ford truck. And below that, you have our solution that is showing how we can operate a high-end in-dash system operating 11 displays. So going from head-up display, instrument cluster, the passenger displays, center stack, wing mirror displays, and a display in the rear view mirror. All of that operated by a dual i.MX 8 system. i.MX 8 Quad Max, ultra high-end solution. And this is a precursor to the i.MX 10 that is under development, so the next generation will do this all in one piece of silicon. Why can we operate here on two chips, all of these different displays, although they have different functional safety requirements? That is a challenge today, because those two never must stall, never must reset. They are high functional safety requirements. These are more entertainment displays. Traditional automotive business usually is operating each of these displays on a separate control unit, and we can combine them now all on our i.MX Quad Max microcontrollers, because we can operate 4 separated hardware isolated islands. Different operating systems if we need to, but definitely operated on one piece of silicon in a way that you cannot exchange malware from one island to the other. So for the first time we can bring up one control unit that's operating everything, where you basically have navigation content that you can move from here to there via the image memory, but you cannot exchange executable code, so you cannot send viruses or malware from the one to the other island. Huge improvement, system cost saving for the infotainment systems, in-dash systems of the vehicle. Now if you move over there, you see here a demo with Unity. This is a company that is doing gaming environments, rendering for gaming environments. And what they did is they ported their solutions onto our i.MX 8 Quad Max. And we have basically a huge display here, and this i.MX 8 Quad Max is operating these rendering solutions. Basically we could do gaming in the driver console. Of course, nothing that you want to have in your manual-driven car, but in your autonomous vehicle, you could use the real estate, of course, for gaming. But what is for me more important, the serious use case, you can start rendering your HMI for the driver, so the other cars around you, in a 3D way using gaming technology, and you can render via augmented reality your solutions using these gaming highly advanced technologies. And if you move with me over here, what you can see again is on our i.MX family a series ready implementation of a center stack and instrument cluster ready made for a product launch here by a Turkish tier 1, a partner from us. Really fast time to market. They did an awesome job integrating this in a fantastic way, and what you can see here is really a ready-to-use system that will see the industrial market in the course of this year. Now, coming from the video side of the infotainment system to the audio side of the infotainment system is basically what you're going to see here. So this nicely designed radio demo, yeah, looks like our car radios are moving into the living room. No, I'm just kidding, but these demos here are so nicely designed in the meantime. They are operating our software-defined radio Mercury chips, and they are operating basically also our BAP amplifiers, so basically the intelligent high-end amplifiers. Now, what is new this year is that in the past, you had your microcontroller running with the radio middleware, and the Mercury chip here is running the software-defined radio algorithms. We have moved a lot of this middleware onto this Mercury chip, so we have a chip of the size of my thumbnail that is operating the entire radio. 6 tuners, AM, FM, software-defined radio and TV, digital radio and TV, and basically there is only a very thin middleware layer still on the microcontroller, and all the rest is sitting on the Mercury, and we call this software stack Aura Light. If you then move with me over here to the amplifier section, what I just said prior at the eye-catcher demos, this is the Harman system that we have here at our booth. Harman gave this to us. Here you see basically our amplifier electronics in this big PCB. Underneath this box. This is the box that is built into the trunk of the high-end cars for high-end sound experience, 16-channel systems, awesome sound taste. And you can see we have all the ingredients from highest end to lowest end in-dash infotainment systems, top-notch. Now, what I have not mentioned yet is these solutions here have already integrated our recent acquisition. So as you might know, is mid of December we closed the deal with Marvell Wi-Fi and Bluetooth. So we bought the Marvell team, and these solutions here are running already on Wi-Fi 6. So industry-ready products. These products go to market this year still, and the mobile phone is running the Android Auto stack and is transporting via Wi-Fi 6 all the data directly into the instrument cluster of the vehicle. So basically that you can operate your mobile phone, you can charge it wirelessly via the NXP wireless mobile phone charging up to 15 watts, and you can run it really in your mobile phone compartment and transport the mobile phone displays, including navigation, all your Spotify and favorite apps onto the in-car infotainment system, and you have it all. Radio, amplification, graphics. Now if you join me,
Yeah, problem. Give us time.
So if you join me, basically just over here, the data pumping devices that we have, the hottest stuff that we have at the moment in the market for gateway electronics. So basically being the data dispatcher in the car, being the device that is highly safe, ASIL-D, that is highly secure, so hacking secure, and that is capable of pumping a lot of data into 20 CAN channels, a lot of Ethernet, gigabit Ethernet channels, is exactly this solution that we have here. Just a second, please. So what you can see here is this is our S32G platform, and the S32G eval boards. They are already out at our customers, out at our partners. They are porting at the moment their software ecosystems onto these things, and from there we can dispatch all the data into the car. Now, that would be only half the story if we would not have the connections to the wiring harness. So if you join me just over here and look at these devices. We had the data pumping microprocessors and microcontrollers. Now here we have the data switching devices, the Ethernet switches and physical layers. So these devices here, you can see here, have 2.5 gigabit outlets, 2 1 gigabit outlets, 100 megabit Ethernet outlets, where our 100 megabit PHYs directly concatenate to those devices. And you have in the range of 20 CAN channels out there as well. So again, what we have is from the central micro to the PHY, we have the entire thing, highly functional, safe, highly secure, including security on those devices, not only on the microcontroller, and you can detect the right files, the right packages that are traveling over these networks and can make sure that the security of the car is not compromised. This will revolutionize the architecture of the car, and this 5-domain model that I'm preaching since years is becoming a reality with these type of devices. Now, if you join me over here.
IoT based.
Of course, what you can see here in our setup is the zonal architectures of the vehicles. So via the blue boxes and via the body electronics that we had here in the demo, via those units, we have door control units set up, where basically via Ethernet communication, via the zonal domain controllers, we can feed information in a synchronous way, for example, to the speakers. We can operate the radar modules that you can see here at the opposite side of the demo. We can operate all the mirrors and all the displays for the mirrors. So all of that connected to the gateways, connected to the Ethernet products that I just introduced, is basically what we will need to building the entire data nervous system of the car. Looking over there where the crowd is standing, we have our radar systems. And Michael, may I quickly jump in here for a second? Just have a look here, please. We have our radar systems here with an antenna in package system, plus what we have, imaging radar, so the big solutions. We have in the market our silicon germanium solutions. We are going to RF CMOS today, and now we are bringing the entire portfolio of scalable systems. Antenna in package, these tiny little copper dots here on the chip are the antennas of the chip. We have then the short-range radars, double front ends with a much higher resolution, and what we call imaging radar, so for 80 gigahertz front ends for high resolution radar. So these type of solutions are really top-notch spearhead solutions for building the optimal radar cocoon around your vehicle. If you join me to the other side of the booth.
Why do you know this guy's production?
So then, of course, what you need to do is you need to drive this entire thing not only from the sensing side via the radar, but also into the thinking side. So you need to compute basically a solution that is really then calculating the driving advice of the vehicle, is doing the autonomous part of the autonomous driving. This is what you see here. This is our blue box, and the blue box is basically our development solution. It has an S32G, one of these highly safe and highly secure gateway microcontrollers as a safety island. Next to it sits a multi-purpose microcontroller, a so-called Layerscape, an LX2 as we call it, both NXP silicon. And these two solutions together on this bottom part here of the platform can do a level 2+ autonomous driving or ADAS-based driving. Now, what we have on top of that is we have 4 PCI Express slots where you're slotting in AI accelerators, and our partner company, Calray, is bringing these AI accelerators to the party. So they have their newest device, the Coolidge, out here on that demo, and you can see here basically the self-driving autonomous demo. We can scale up somewhere between a level 2 and level 4 autonomous driving on these scalable, growable platforms. The next thing that you see here is the Automotive Demo on ultra-wideband. So the ultra-wideband that I had introduced prior is basically here shown in the car ecosystem with a couple of ultra-wideband beacons, how you seamlessly access the car, how you get in and out of the car, all with this ultra-wideband silicon that you ideally have in your mobile phone or in your smartwatch even. And this will replace the entire key ring in your pocket that you are wearing today, including the car key, and we have an enormous traction with that. So after I told you all the things about how to sense your environment and how to think of a driving advice for your car, of course what you also need to do is you need to make sure that the car starts driving. So you need to steer and move the car. So what we have here is, this is reference designs that we are doing with our partnering companies. Reference designs basically doing all the powertrain movement, operating the motors, steering the IGBTs and silicon carbide switches. So we don't produce these silicon carbide switches and IGBTs. All the rest is NXP based and is basically a complete ready-to-use reference design for powertrain units driving a couple of 100 kilowatt motors. Now, this is the drivetrain part. Where do you get the energy from? Well, this is another nice NXP story. iCar has worked with us on a battery system here, and our battery management electronics is really in high demand at the moment. But what you can see here is they have a very revolutionary battery design, and here we have our battery management electronics to optimally make sure that these battery packs have the optimal energy content and that you can get maximum energy also out of the battery pack if you need it. So driving range is the key topic, and functional safety. NXP can offer both highest precision analog electronics and highest level functional safety so that these battery packs are really operating at their max. Now, if you want to see how this all comes together, of course, you can have a look here at this shrunken demo, battery management demo, how we manage our powertrain units here via this green box, how we operate with the gateway solutions, the S32G, all nicely put together here, and you can see how, in principle, the life cycle of a powertrain of a vehicle looks like. All NXP built, NXP operated, and we can really be a trusted advisor to our partners if you want to do these type of things. Now, if you join me moving out of the automotive area, more into the industrial area, what we're going to do over here, what you're going to see is how we operate our industrial setups, industrial footprints, how we operate, for example, via the use of digital twins, manufacturing infrastructure, how we are connecting in a secure way to the cloud, how we basically manage trusted devices in your industrial environment. And join me further just around the corner here. What you of course need for that is proper networking also on the industrial side. And you see here the TSN networking, so Ethernet-based networking, industrial standard networking that you need for industrial robotics and industrial electronics. Now, as said prior, security is of the essence. Here is the SE050, our secure element for the secure connections of industrial assets to the cloud. And basically what you can see here is how the system, in case of an hacker attack, would flag that there is someone trying to attack the system and directly goes into a safe state and makes sure that nothing is compromised. Now, going from this heavy-duty industrial equipment over to something that is very, very close to my heart. Gerald has it here. This is our drones, where we just try to show if we can drive, if we can manufacture, we also can fly. And basically we are using a full set of NXP electronics to fly in a functional, safe way, in a highly autonomous way, drones. So these are drone kits that you can order from the internet that students can build and work with. And Gerald is even working with a little rover here that is following him in an autonomous way, or basically an optical steered way. And this little rover is a drone carrier that is even following him like a dog. So he doesn't need a dog at home anymore. He just needs this follow me sign and has his own digital pet following him. Gerald, thanks a lot. Hey, move on with me. To the energy management of consumer electronics, of course. Now, what you're gonna have is, we have all this nice wireless technology. I told you prior about the Marvell Wi-Fi and Bluetooth portfolio that we are bringing in, all the other technologies that we have at hand. But this is all nothing if you cannot charge wirelessly. So what we have here is we use our NFC technology for charging very tiny devices. So a stylus pen, a small smartwatch, earphones. Then what we have is the mobile phone charging. And we have even a high power laptop charging, 65 watts. So all these solutions, very important is this one here also for the automotive domain. Why? Because in the automotive electronics you get your navigation systems in the meantime on mobile phones. You have Android Auto or Apple CarPlay running. Nevertheless, these solutions consume more than 5 watts on a normal mobile phone. So if you don't charge your phone properly, your phone gets depleted. Normal chargers only have 5 watts. NXP has 15 watts lined up. So you can still charge your car while fully running those tools on your mobile phone. and transport it into, as you have seen over there in the automotive section, into your displays of the e-cockpit. So basically you just put your mobile phone down there in the glove compartment, it's charged, it's fully operating, and you can see it seamlessly on the in-car display. So join me to the other consumer electronics over here. A thing that I'm super proud of is this here. This is our biggest out of the mix microcontroller. It's an 865 just since 2 weeks out of the factories. So the team did an over Christmas present for me, a bring up here within 2 weeks. This thing is fully running, and the new thing here is this has a 2 teraops AI accelerator. The first AI accelerator phone, NXP, on a microcontroller. Now, what you see is, have a closer look at this one here. You don't see any cooling equipment. Yeah, this entire device is running here. Face recognition is recognizing people without a lot of cooling electronics. So, in other words, without a lot of power dissipation. This is, of course, the entry ticket for having a lot of at-the-edge AI-based systems. So having basically your front door camera running in a power-efficient way, doing surveillance cases, doing sorting cases in industrial activities. So sorting screws or products, beer bottles, whatsoever, what you like, what you have on your conveyor belt. All this can be done for a couple of dollars here on these tiny edge solutions. In 14 nanometer technology, we have it here at the moment, really spearheading the edge smart connected device industry. What you then can see going down here is, of course, a lot of biomedical sensors, a lot of the other AI electronics, where we are basically trying to find anomaly detection, where we are trying to sense the analog world, trying to understand what is not going as it is normal, and where you then have basically to interact with your electronics. Now here, what you see is a very different segment. This is what NXP is doing in the 5G and data pumping domain. So you see here, for example, data connection via our base stations across glass windows. You see here down the aisle our Wi-Fi 6 solutions, our base station solutions based on our big microprocessors on the Layerscape portfolio. And you can see here also how we have on i.MX 8 again, together with the newest Marvel products, Wi-Fi 6 and Bluetooth integrated, so that you also have for portable devices plus for inbuilt systems exactly the optimal networks set up. And in these red boxes here behind me, you can see the hottest and greatest Wi-Fi 6 solutions that are coming in from Marvell. So we don't have only blue boxes and green boxes, we have red boxes in the meantime as well, here Wi-Fi based. So if you just join me around the corner.
Something that has a limited lifetime and then gets replaced.
And what you're going to see here is, this is basically the next level of 5G electronics, our LNA business, our smart antenna business, where you basically can, you see it here sketched on the screen, where you can start optimizing your 5G, your learning networks, via changing the antenna characteristics via beamforming, via our top-notch, world-class, leading-edge low-noise amplifiers in the smart antennas, and you can optimally connect these buildings with plain vanilla antennas, non-beamforming, that would not be possible. So we show how we optimize with learning systems and configurable antennas our systems here. Now, you see this here as well going forward, 5G solutions, how we optimize on learning networks, and then how we go via hearing aid solutions, very efficient, highest end hearing aids, also into building control. So the entire segment of smart home, smart building control, smart consumer gadgets. If you follow me around the corner, the last few things that I'm going to show you, here is a complete sound studio where we have the latest and greatest sound equipment built in for highest quality, lowest cost soundbar solutions. So getting really top-notch sound experience, world-class sound experience into your home entertainment, and having really on our i.MX microcontroller portfolio here super breakthrough system cost downs for the soundbar makers of the world. Now, down this aisle here, what you're seeing is, you're seeing our solutions for machine learning and recognition. And the camera here is at the moment pointing to these learning little systems here, Alexa-based systems, Alexa-certified systems. And these Alexa-certified systems are working as a complete voice assistant based on our RT microcontrollers, crossover microcontrollers. You see the same crossover microcontrollers here doing face recognition. So very, very cheap solutions that can do basically your front door face recognition, surveillance camera triggering, or smart home manufacturing. Again, said this is off-the-shelf ready systems from NXP. You can order them on the web, and what you can do is you can basically build your own solutions with it. So what you see here is one of our cool system demo kits. You can order these things directly from the internet, and the cool thing of this thing is that it is Amazon Web Services certified already. So with this pre-certified solution, the team was able, from idea to product in 4 months, to build complete Alexa-enabled light switches, including a complete Amazon Echo Dot. And that is, of course, what is a fantastic thing for our customers, for example, for washing machine producers, microwave oven producers. Just take these tiny little systems, integrate them into their systems, hook them up to their serial port, and the device is suddenly Alexa enabled. So ultra cool stuff here on our small RT microcontrollers. If you just follow me over here, sorry. Basically down here, what you have here on one of our RT microprocessors as well. So for a couple of dollars, you have here a noodle sorter demo. Just checking out whether these noodles are okay, camera-based AI, just checking what is good, what is bad, doing simple AI at the edge in these portable devices. And this is of course exactly what you need if you want to have simple surveillance systems, simple industrial optimizations, and this is what we can provide to the industry. And even hotter, what we have over here with the Google TPU and our Layerscape chips enabled is basically a system that can go for tissue examination, so medical histological examinations, scanning body cells for cancer. Much, much better than any radiologist can do this. Ultra hot, ultra cool, and of course will drive us into the next level of medical quality. Or even here, same setup, an i.MX 8 and the Google TPU doing complicated sorting exercises. So sorting different pieces of screws into different buckets. You learn it, you train the system for 10 seconds and off it goes and immediately starts sorting. Ultra simple, ultra fast, ultra efficient. Even here, if you're looking to these solutions, you can enhance this also to face, gender, emotion recognition, which is of course key for all sorts of access and autonomous device conditionings. So in other words, I hope I could explain to you how much we will be in future in all these 75 billion smart connected devices that we expect to be in the market in 2025. That NXP is in a pole position with its portfolio in a lot of those areas, and that we only need your help, your inspiration, your teamwork to jointly craft with us all these highly innovative smart connected devices in future. Please take us as a trusted advisor, contact us and play with NXP. Looking very much forward to talking to you in direct contact. Thanks a lot, take care.